Okay, I'm going to try something here. I just somehow lost the first 30 minutes of this lesson. So I'm going to try something here and we'll see how this goes. In today's lesson we are going to talk about triangles. So I need you to forget that you already know anything about triangles, okay? So we're going to say that a geometric figure is a triangle. That's your first blank there, triangle. And we're going to use the symbol for a triangle if it and only if it consists of three coplanar segments with endpoints in pairs. So what this means is we have a three-sided polygon. We haven't really talked about the word polygon yet, but polygon means that it's an enclosed figure. Okay, so we can all look at this shape ABC, and the A is really supposed to be down here in the corner. Okay, but we can look at this and say that A, B, and C are all vertices. So A, B, and C are all vertices. And I think that also goes down there at the bottom, like kind of under the parts of the triangle it says vertices. You can put that there if you'd like to. Okay, so we name a triangle with three letters. So first of all, we're going to use the little triangle symbol, and then we're going to use any combination of the three letters. So we can use a triangle A, B, C. And then think of another example that we could use. We could use triangle BAC or CBA. Any combination of the three letters. Okay? So I know that when we were dealing with angles, it mattered, the order, but when we are naming triangles, the order does not matter. Okay, so any three letters, and there are more examples that we could use as well. So after we've named any three letters, then we can name the sides of the triangle. So if we look at the sides of the triangle, the first side I'm going to look at is going to be side AB. And because it's a segment, I'm going to use the segment symbol. So because it's a segment, I'm going to use the segment symbol. Alright? So that's one side. The other side is going to be side BC. So side BC. And then I'm also going to put the line segment above that. And then last but not least, okay, so I've named AB, I've named BC, so now I'm going to name segment AC or side AC. Again, the segment bar above that as well. We've already talked about what the vertices are, that means the endpoints. So let's go ahead and list those here. Vertice A, comma B, comma C. That means that they are, we said endpoints. So let's write that they are endpoints. So we know that vertex A, vertex B, and vertex C are all vertices of this triangle. So now that we've talked about the endpoints and we've talked about the sides, let's talk about the angles. So the angles that we see represented here, okay, we have angle A is going to be one of our first angles. And so we're going to say angle A. We're going to name it angle A. The next angle we can see is angle B. We'll name that angle B. And then finally we have angle C. And I know that when we were naming angles, I said typically I didn't want you to use just one letter, but there is only one angle coming from each vertex. So it is appropriate and okay to use just one angle in this situation. Okay, so we have three angles, we have three sides. So now let's look at a couple of examples. If it's asking you to name the side that is opposite angle C, it's asking you for the side. And one of the things that's a frustration for me is when in the problem it says side, but students write an angle. Make sure that you are paying attention to what the question is asking. If it asks for an angle, give me an angle, which is named with one letter. If it asks for a side, give me a side, which is a line segment. Don't just tell me an angle when it asks for side. That's a huge frustration for me. So if we look at angle C, the side that is opposite angle C, so we're going to draw an arrow across from angle C, and the side that is across from angle C is side AB. You guys see that? Side AB. So we'll go ahead and list that there. The side that is opposite angle C is AB. And because it's a line segment, we're going to put the line segment above it. So then the next one asks to name the angle. It says name the angle that is opposite side AC. So let's mark side AC. And across from AC is which angle? Well, we would say that that is angle B. And I'm using two hash marks because or two arc marks because I've already used one when we were talking about our angles. So across from across from side AC is angle B. Now we have something that says name the angles that include side AC. Name the angles that include AC. So we haven't talked about this word include yet, but include means between. So the question is really asking which two angles is AC between? So let's look at this. So we've already marked AC. So we're talking about the angles, so they want me to give two angles that include AC. So if they include it, we're going to go ahead and talk about the way that it says AC is between which two angles. That was written really fast. You don't need to write that down. But do you see up there we've marked that segment AC is between angle A and angle C. So we're going to mark the angle, that segment AC is between angle A and between angle C. So between is another word to think about when it says include. So the next one says name the sides that include angle C. So let's look at where angle C is. So angle C is here. What are the sides that include angle C? Another way to ask that is angle C is between which two sides? So angle C is between AC and it's between, so let's write that down, AC, and it's a segment, and BC. So it's between AC and between BC. So that's our second side there. So in your homework, if it's asking for sides that are opposite or angles that are included, this is the section of your notes that you're going to want to come back to, okay? All right, so let's go ahead and talk about including a triangle by classifying it by its angles and its sides. So that's what we're going to write there. A triangle can be classified by its angles and its sides. So the first type of triangle that we're going to talk about is called an acute triangle. An acute triangle, we've used this word before. Remember, we used it and it was less than 90 degrees. So an acute triangle says that all angles are less than 90 degrees. All angles are less than 90 degrees. So this is an example of what this triangle might look like. It might look like this, where it's a little bit smaller, but all the angles are smaller than 90 degrees no matter which way you turn. So that's an acute triangle where all angles are less than 90 degrees. The next kind of triangle is a right triangle. And in a right triangle, there is one angle that is 90 degrees exactly, but only one. It has one right angle. And this is a diagram of what this one might look like. Remember when we draw a right angle, we talk about how we have that little box there, okay? So a right triangle has one right angle. The next type of triangle we can talk about is called an obtuse triangle. Remember what we talked about obtuse. Obtuse means that it's greater than 90, right? So in an obtuse triangle, you have one angle that is greater than 90 degrees. One angle is greater than 90 degrees. One angle is greater than 90 degrees. Okay, so this is an example of what this one might look like. Where that angle there at the bottom is an obtuse angle, okay? This would be an obtuse triangle when one angle is greater than 90. And then the last type of triangle that we can talk about is when all the angles are 60 degrees. If all the angles are 60 degrees, and we'll figure out, or we'll talk about why in just a minute, 60 is an important number. But if all the angles are 60 degrees, then this is going to be called an equiangular. Equal angles is what it's saying, basically. So equiangular. So a triangle is equiangular if all the angles are 60 degrees. Equiangular. So these these four ways are how we can classify a triangle based on what the angles look like. Now, not right this second, but at some point today, you need to take out your vocabulary sheet and add all of these vocabulary words that we're talking about today into your vocabulary sheet. Again, do not get it out right now, please, because then that means you're not going to be paying attention to what I'm saying. But at some point today, after the lesson is over, you need to get your vocabulary sheet out and add all of these words to your vocabulary. So the next way that we can classify a triangle is by its sides. The first way is if we have no sides that are the same, we say that the triangle is scalene. So this is a new word, scalene. No sides are the same. That's what scalene means. No two sides are the same. So this is maybe what this triangle would look like if you were to have a scalene triangle, where all three sides are obviously not the same size. The next type of triangle is when we have at least two sides are the same. This is what we call an isosceles triangle. Isosceles, and this is spelled kind of funky, so please look up at the board. Isosceles. I like to remember that an isosceles has two congruent sides because you have two S's and two E's there. Isosceles. So this is maybe what an isosceles triangle looks like, where you have two sides that are the same. And we make these little hash mark things to represent congruency. Because if two sides are the same, then we need to mark them the same. And so we're going to make these little hash marks. And maybe off to the side you can write that the hash marks mean congruent. Okay? So these little hash marks mean congruency. The third type of triangle that we can classify by its sides is an equilateral triangle. Equa meaning equal, lateral means sides. So an equilateral triangle. Again, equilateral means all three sides are the same. So if all three sides of my triangle are the same, then that means that I need to mark them all the same. Okay? So again, we can have a triangle that we would name or classify by an angle. So we would say that it's either acute right, obtuse, or equiangular. And it has a description based on the type of sides. So let's look at this triangle that I'm going to draw up here at the top right. If I were to draw a triangle that looked like this, these two sides are the same and a right angle there, let's go ahead and name it by its angle and by its side. So we say that it has one right angle, so we would say that this is a right triangle. But not only is it a right triangle, it has two sides that are the same. And if it has two sides that are the same, then we would say that it is also an isosceles triangle. So this is a right isosceles triangle. Two descriptions based on the angles and based on the sides. So a right isosceles triangle. All right, let's look at some examples here. If I am looking at this example, before I talk about this example, what it says up here in bold is really, really, really important. Okay, so let's highlight this, mark this box, this square, this something. It says the sum of the measures of the angles of a triangle are 180 degrees. The sum of the measures of the angles of a triangle equals 180. What that means is all the angles inside of a triangle will always make 180 degrees. Always, without a doubt. That's the definition of a triangle. So let's draw a triangle over here to the side, and let's set up an example problem. If I tell you that one of the angles is 60 and the other is 70, how could we figure out how much that third angle is? So we know that one of them is 60, one of them is 70, and if we don't know that third angle, we could call it x, right? And we just learned that all three angles in the triangle add up to be 180. So we can add 60 plus 70 plus x, that's all three angles, equals 180 degrees. Okay? Let's go ahead and solve that. You solve that on your paper. Find out how much that missing angle is. So we know that 60 plus 70 is 130, plus x equals 180. If we subtract 130, we get x to be 50. So that means that third angle in our triangle is 50 degrees. That's the type of problems you're going to be doing in your homework today. That's the work that I want to see. This equation written out. If you don't know an angle, you call it x. This is what I'm looking for. Okay? All right, it's also really important that you know that sides never equal 180. I tell you that, but some of you will set up the side measurements to equal 180. But just for the sake of me telling you, let's go ahead and write that at the top of our page. Sides never equal 180. So unless they're giving you an angle on the inside of a triangle, I should not see 180 on your paper. Sides never equal 180. Ever, 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 ever. Okay? You will always add up your angles to equal 180, but not your sides. So let's look at example A. It says triangle RST is equilateral. Remember, we just talked about what equilateral means. Equilateral means that all three sides are congruent. So let's go ahead and mark all three sides to be congruent. If all three sides are congruent, it's asking me to find x and the measure of each side. So if all three sides are congruent, I can go ahead and set the two sides that I do know congruent to each other. It doesn't matter that I don't know that third side, because if I can find one, I find all, because they're all the same, right? So let's go ahead and set equal x plus 9 equal to the 2x. So x plus 9 equals 2x. Let's go ahead and solve this for x. We're going to subtract x on each side. We get x to be 9. Now, they asked me to find x, which I did. That's the first part of the problem. And then it says find the measure of each side. But it doesn't matter which side I choose because they're all going to be the same. So I just picked ST. So we could say ST is represented by 2x, but instead of x, I'm going to put in my 9. So I'm plugging it back in. So I know that 2 times 9 is 18, so ST is 18. And again, I know that all three sides are the same, so if ST is 18, then that means that RS is also 18, which means that RT is also 18. All three of them together, all three of them are each 18. Now, we don't know if it's 18 feet or 18 inches or 18 meters, but I know that they're all 18. Notice 18 plus 18 plus 18 does not add up to be 180 because sides don't, say it with me, sides do not equal 180. Okay? All right, example B says that we have triangle DEC with vertices listed here. Let's go ahead and classify the triangle by its sides. Well, I can't classify the triangle by its sides if I have no idea what it looks like. So the first thing to do is to graph these 3 points. So let's go ahead and plot these 3 points. As I do it here, I want you to do it at your seat on your paper. You know how to graph. Set the X first, then the Y. Please make sure you label the points as you are graphing them. So D is at 3, 9. E is negative 5, 3. And then C is 2, 2. Now, because this is a triangle, let's go ahead and connect our points. And if I want to classify this triangle by its sides, I need to know the measure of the sides. Does anyone know how to find the measure of a side? Think about something that we have used so far. Anyone? I hope someone said the distance formula. If so, give that person a high five. Thank you. Okay. So the distance formula, remember, is our old friend here. Let's go ahead and write it down on our paper again. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so what I'd like you to do first is I'd like you to find the distance of DE. Find the distance from D to E. I want you to make yourself organized, so please over there to the side write DE. Okay? Now you don't need to look up at the board to do this. You know how to do this already. So I want you to find the distance from D to E. Take a few minutes to do that, please. Find the distance from D to E. Be careful with your negative signs. So we know that 3 minus the negative 5 is 8. We'll square that. 9 minus 3 is 6. We'll square that. So we have the square root of 64 plus 36. which is the square root of 100, which the square root of 100 is 10. Please remember, after you take the square root of a number, you no longer have the square root sign. You just have 10. Okay? So let's go ahead and write 10 on our diagram. Oops. Something there messed up. So let me put this back on there. 3, 9. Oops. Okay, for the sake of time, I'm going to go ahead and solve the rest of it out for us. This means I need to be doing the distance formula 3 times. If I have 3 sides, then I need to do the distance formula 3 times. Okay? So let's go ahead and write out what EC is, and let's write out what DC is. We'll give ourselves blanks, and I'll go ahead and figure that for you. But please write down the distance formula 3 times at the top of your page. That's what we need to make a note of, so that if you have to do this in your homework, you remember that you need to do the distance formula 3 times. Okay, and then down here, let's go ahead and label what EC is and label what EC and DC is, and I will speed this up because I already did this for us. Wow, look how fast that is. Again, I know you know how to do the distance formula, so on your paper, I'd like you to write that EC is the square root of 50 and DC is the square root of 50. You don't need to show the work right now because I did it for you. Don't panic on me. Just write down that EC is the square root of 50 and DC is the square root of 50. Again, I know you can do the distance formula, which is why I'm not making you do it right now in the notes. But the square root of 50 rounds out to be about 7.1, so that's what we're going to put on our diagram, is 7.1. So I know that DC is 7.1 and EC is 7.1. So if both of these are 7.1, two sides are 7.1, so two sides are the same. What kind of a triangle, if we're classifying it by its sides, look back if you need to. If two sides are the same, that means we are classifying the triangle by its sides, and we would say that triangle DEC is going to be an isosceles triangle. So let's write that. Triangle DEC is isosceles. DEC is isosceles. Okay. All right, let's go to part 2 of this lesson.